So yeah, I'm basically here to play you out, and I will do that by giving a programming talk. But I decided, because it's late, everyone's probably tired, I will show not so much code, but I give you an overview. This will still be like pretty technical, but at first I will show you what our app is about, what it can do, and then we will come to the spatial audio part, which is actually just like one feature of our app. And to be honest, compared to all the other software shown today, it's kind of tiny, but I think it's still interesting. Also, maybe me recollecting how we got into this, or because this was, as a developer, my first contact with spatial audio, which can be kind of daunting. Okay, so yeah, Jakob already teased you a little bit about our app. It's called, Sonic Moves. It's a digital platform for body interactive sound. And by that we mean that we have an integrated platform that lets you interact with sound compositions through body movements, just using your device's camera. By that we mean the camera of your iPhone or your iPad or your Mac soon. And I think it will be best if I just show you a little video of like a performance captured on it. Oh, by the way, everything today here will be in stereo, which I heard is the favorite format here. Because we are only using binaural rendering, and yeah, we couldn't in time do any other like multi-channel layouts. So I will show a little video that I captured of the dancer Tomoko. She interacts with a composition made by Jakob, and everything, like the whole changes in the sound here, are depending on her movements. We should hear sound. It goes to pitch. Okay. Yeah, let's see. Great, it's not loading now. Okay, that is. Yeah, maybe. Okay, that's enough for now. What you just saw is basically, like, as I said, a composition that was made in Sonic Moves. So the basic principle is that we have this real-time 3D body tracking, we have this editor, and when we have this player app. So we basically have two apps. One is just a playback app that anyone can download for free, and any composition that was made with Sonic Moves can be played there and can be interacted with. So it's like a plug-and-play system. It's basically just a library with body interactive compositions. And then we have the editor, which we call the Sonic Moves Creator for Mac and for iPad. And that is the tool in which these body interactive compositions are made. So it's a node-based systems where you can parameterize all the effects and connect those to body movement inputs. You can also trigger note playback. You can change different musical properties like note transposition, octavation, in different scales and so on. Yeah, so it's pretty powerful, or by now pretty complete in this feature set. So here you can also see it like running in the editor, like playing. So this is what the composer sees before exporting the file and then as a single file and then sending that to someone. And as you can already see here on the right, there are these 4 dots. These are our 4 optional sound sources, spatial sound sources. We limited that to 4 right now just to be sure that it's not overwhelming the processing. It's an arbitrary number. Yeah, so this is what our app does. And yeah, I already told all that. As you saw, maybe it's only available on Apple platforms. I say that not as an endorsement of Apple, but just so you understand our tech stack. And we have an interactive music engine that I programmed, but it is built on a library called AudioKit. That is an open source project, an amazing open source project for audio on Apple platforms, so audio programming on Apple platforms. I don't know if anyone ever got in touch with this topic at all, but Apple's audio frameworks are powerful, but also a little bit finicky to work with. And so AudioKit started as a wrapper for some core functionality, and then it extended more and more. It's very performant because the critical code is written in C++. But as a user, so as a developer, you interact with it through Swift. So that's a newer language than the original Apple frameworks were written in. By now, it's a collection of many libraries that can be very useful. I can maybe just show the website shortly. So apart from the core functionality of wrapping the AV audio engine from Apple, it has lots of custom nodes for effects, sound generation, synthesis, audio playback, and so on. It also has libraries for music theory, microtonality, UI elements, and so on. So it's really pretty powerful. Maybe anyone knows C-Sound here. From that came a project called SoundPipe from one of the people of C-Sound, and that was also ported to AudioKit, and it's also quite powerful. I know this is very much into the weeds, but that's just the topic of my talk. Okay, so we didn't have spatial audio from the start, but we thought it would make sense very much if you have this immersive, interactive sound environments that you kind of control with your body. Would be also interesting to have spatialization, spatial audio in that. So we were looking into how to do that. I did write a little panner myself, my very first one. It was shit. So yeah, I threw that away pretty quickly, and Jakob fortunately discovered something called PHASE, which we use now. So our main goal was, of course, to render spatial audio in like binaural, because it's for headphones. And it would be extra nice if we would have the so-called personalized spatial audio, which means that, as we heard before, like 2 talks ago, which means that the audio sources would be virtually fixed while you are moving your head And that, of course, only works with devices that support this kind of movement detection, like these Airpods Pro, Beats, whatever Pro, and so on. Yeah, and that by now already comes with the Phase Engine. Before that, we had to do that manually, but that wasn't so hard to do. So what is Phase? Phase is Apple's physical audio spatialization engine, which was made for like dynamic environments. So you can think games or other immersive content. So the concept is that of a 3D scene. Like in a game, you have not a camera, but a listener that has a position and an orientation. And then you can have different kinds of sound sources. You can also have environment objects or environment geometry, which can occlude or reflect sound. It can have different materials. And so, yeah, when you think about it, it seems really to be made for games. It's organized in a graph, like a scene graph from other 3D rendering systems. SceneKit by Apple is one of those. And it's asset-based, so you are loading files from a URL, so you can stream. You can also have resident files, which like files on your drive, or you can also just provide it a data stream, so like buffers, and it also can then render that, and it takes care of all the spatialization. Yeah, there's a little link here. So here are some properties. It has different sound mixer types, so basically 3. One is just basically a center that can render the audio that you give it in stereo or mono. That's for narration or whatever. You can have ambient mixers for like sound beds. Those are spatialized using their position or their angle around you, but not calculate or not taking the distance into account. And you can have objects like dynamic sources that can move through the sound, and the distance and other geometry is also taken into account during this physical simulation. You can use a sound propagation type. We use a very similar one, which is basically just taking the distance into account for the loudness. You can have an optional fade-out range, which means that you can set a scale in meters, and after any sound that is further away will just fade out. Roller factor is a multiplier for that. You have early reflections, reverb, these known reverb room sizes that you might have seen in other reverbs, like chambers, medium room, etc., and of course the center level. And so our problem was, how do we get this sound that we are producing in our music engine using AudioKit into the Phase engine? That was basically the main problem. So the way that AudioKit works, and that I guess almost all of audio rendering works, is that there is an engine that requests at a given interval, like at the buffer size, requests the next buffer to render or to put out to the system output, and then the audio engine of AudioKit looks into all its inputs and their inputs and so on, and pulls all the data that it needs for the next buffer. And that is very easy to use in AudioKit, but we need that data. As I said, you can also stream data to the Phase engine, and luckily AV Audio Engine and AudioKit, they have something called tabs, so you can tap into sound sources and also request the buffers from there, the samples. And that's what we do. We are still using the audio engine of AudioKit to get everything running and have a very nice and easy setup, because AudioKit takes care of all the formatting stuff and buffer size and so on. And so we keep that running, but internally we mute it. And then we get through these tabs from all the nodes, we get the sound data, and then we send that to the Phase engine. And the nice thing is that every one of these tabs and each of these nodes can be one source, one object in the Phase engine with a certain position and its own like properties. So to integrate that, I wrote a spatializer class in Swift, which includes an instance of a phase engine, an instance of an AudioKit audio engine, the listener, like you, and an optional head motion manager, which as of iOS 18 we don't really need anymore because Phase does that for us. And then in the spatializer we have our so-called spatial nodes, and each of the spatial nodes includes the input node, a tab, and a position, and they are all updated automatically and sending data to the phase engine. And now I'm sorry, but now it's time to show you a little bit of code because that's just how I prepared my talk. I don't know, is any Swift developer here? Hey! So I will show you, I don't know, I would just step through the code kind of quickly and show you how to set up a phase engine, even though you will never do that. I have this class here, I just called it audio, it's a cool name. And then when right now I have just one source here, which is an audio player, which loads a file. And then I initialize here my spatializer class, which is doing most of the work. And after I set it up, then I can start it, I can stop it, that's it. I can also translate something. So this is this spatializer class. It's not that big. So it has an instance of the phase engine, an AudioKit audio engine. It has a list of sources, of spatial nodes. In this example, we have only one. We have one listener. There's always only one listener. And when we initialize, when we set this programming object up, then we create a phase engine. We tell it, okay, what should be the first the update mode. Automatic is the easiest, and I don't know why you would use anything else. You can set the output spatialization mode, and that's maybe is still valuable even if you don't understand any of this code. I will go through some of the parameters and what options there are. So here we can choose automatic, but if I click on it, there's also the option to always use binaural or always use channel-based. So this is one property that we can set. Then we set up a pipeline, and in this pipeline we can put some flags. I just put all of them, like direct path transmission, early reflection, and late reverb. That's pretty much all there is. Then I create a mixer. That's not very interesting. Then I create a distance model, and here in this case I have this phase geometric spreading distance model parameter, which is basically what I said earlier. It's just a very straightforward way of the sound volume as a function of the distance and the other geometry. I set fade out parameters. That's what I said before. You can fade the sound out if it's at a certain distance. Here I put a distance, it's in meters. So this is almost 5 meters. So basically around me I have a radius of a little less than 10 virtual meters of sound objects, audible sound objects. Then here in my initialization, the user can submit a room size and a reverb send level that I will then set here. And then I have my phase engine almost set up. I have my listener here that I create. I put them in the center in this 4x4 matrix. And then here, as I said, this is all a graph. So the phase engine has a root object, and to that root object I attach the listener. I could also attach them to another object further down the tree. I don't know why that would make sense, but yeah, maybe for some use case. Okay. And then I have to create my spatial sound sources. Right now I have only one, but it could be a list, so that's why I'm iterating through this list. And for each of these inputs, I create a spatial node with, so if I scroll up here, You see these inputs here. They are nodes and positions. Right now, we only use X and Z, so the lateral direction and the depth. We're not using any height data, so that's why I only pass X and Z here. Okay, and so I create this spatial node here. I give it some parameters that it needs. And this is really the most complex part of the whole setup. So first I create an AudioKit mixer for my input. But here is the real meat. So for each of these sound sources, they need a shape. So I create a shape from a mesh. The mesh is a icosahedron that is just basically, you can see it as an approximation of a circle. So it's a platonic shape made of triangles. So I have this shape, and I give this source this shape. Then to this root object of the phase engine, I add my source. And then I can provide a layout tag for the audio channels that my source has. So I have to know what channels my source has. There are quite a few actually. So here I have just stereo because I have a stereo source. But you can see here there is support for quite a number of different formats. Okay. Here. There's some other bureaucracy I have to do here. I have to give it an ID so that everything can be referenced and the engine knows about everything. I give it a format. I just use the format of the rest of my audio engine. And then here's, but this is actually an interesting part. So this push node definition is what I need to basically later tap into my audio data and get it back and send it to the phase engine. So here I set a calibration mode, relative SPL at 0. And then I register my asset. As I said, it's asset based. So every asset that you want to use, you have to register with the engine so it knows it's there. It seems all a little bit, I don't know, over complex, but I'm maybe a bad person to judge that because I have not used all of it. It's just a tiny sliver. Then I create my tab, which is something from the AudioKit library, which has a mixer as a source. Then this buffer size here, and callback queue. That's not interesting. And then I set up my mixer parameters, and here it gets interesting again, because here I can tell phase, okay, this is a spatial mixer parameter, so it's an object. I could also use an ambient mixer, that would be a sound bed, or I could use this other very simple one that I don't recall the name of, but that's the one that just renders in stereo in the center. Then I finally can create my stream sound event, and then I can tell my tab, okay, this is the stuff, or this is the sound event that you need to push data to the phase engine. And yeah, when I start it, then it starts. That's basically it. I can always change the position of the source, of course, right now I'm just using these two values, and I just put it into this matrix, but it could be like any orientation position. And just to give a little example of how it sounds, I will start Sonic Moves. Yeah, see, this is even riskier, building live. Yeah, but it works. I don't know. Okay, so this is the Sonic Moves creator interface. It's a project-based software, so here are my projects. Most of them are test projects, like this one. So this is an almost empty canvas. I have two nodes here. This is a recording of birds, and this is a wind. They are, I think they are already in mono, but they would be mixed down to mono anyways because they are just sound sources in the world. And then when I play this back, you can see here I've already connected them, like one to this source and one to this source. And when I play that back, I can move the sources around. Is that audible at all? Okay. Yeah. So that is the result of all this hard setup work. Yeah, so that is already it. We have a few things that we could or would like to do. So one thing right now, when when the source position is set, it cannot be changed by the player right now, but it would be nice maybe, or at least an interesting idea to let the players also like play with position of the sounds. We are also not animating them right now because we think it would be overwhelming or a little bit, I don't know, maybe you've been in spatial audio concerts where everything is moving and then you are also supposed to move through the space also, and it's just too much. So that's why things are not animated right now, but maybe it would be interesting at least to move sound sources around with your hands or something similar. So that would be nice to implement. And another thing is that we right now only use binaural rendering, but PHASE can support up to 7.1. So we are also looking into supporting that, so multi-channel layouts. Yeah, and with that, you are free.